Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smartyurl.it/Jedi. My advice on how to pass actuarial exams is at smartyurl.it/pass. This video channel is at smartyurl.it/pass actuarial exams. Here you can find information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smartyurl.it/actuary. If you would like to make a tax-deductible donation to support our students, please go to smartyurl.it/help-ISU actuary. Here's a problem for today for exam P on probability. Each time a hurricane arrives, a new home has a 0.4 probability of experiencing damage. The occurrences of damage in different hurricanes are independent. Calculate the mode of the number of hurricanes it takes for the home to experience damage from 2 hurricanes. And here's the solution. So each hurricane arrival is a Bernoulli trial with success defined as damage inflicted on a home, and the probability of success is 0.4. The number of hurricanes it takes for the home to experience damage from 2 hurricanes is the number of times you have to perform this Bernoulli trial until you have 2 successes. And that random variable, call it x, is a sum of a negative random variable, let's call it k, with r equal to 2, and the deterministic number 2 as 2 damages is what we are waiting for. It's so that x is equal to k plus 2. K is negative binomial. Its probability function is the probability that x is equal to n, which is the probability that k is equal to n minus r, where r is the number of negative binomial random variable. And that's equal to n minus 1, choose n minus r times p to the r times 1 minus p to the n minus r. So that's the same as n minus 1, choose r minus 1, p to the r times 1 minus p n minus r. That's what you know from the definition of the negative binomial random variable, and you need to know that for the exam. And we substitute r equal to 2, so this becomes n minus 1 times 0.4 squared times 0.6 to the n minus 2. And we see that the ratio of the probability at x is equal to n plus 1 over the probability at x is n is n times 0.4 squared times 0.6 to the n minus 1 over n minus 1 times 0.4 squared times 0.6 to the n minus 2. So it's 0.6 n over n minus 1. And this ratio equals 1 if n is equal to 1 over 0.4, and that's equal to 2.5. Well, of course, this value of n is not possible, but we see that 0.6 n over n minus 1 is greater than 1 when n is less than 2.5, and it's less than 1 when n is more than 2.5. So as long as n is less than 2.5, probability at x is equal to n plus 1 is more than the probability at x is equal to n, while as soon as n is more than 2.5, subsequent values of probability function decline in relation to the current value. In other words, probability of 0 is less than probability of 1, less than probability of 2, less than probability of 3, but that probability at x is 3 is greater than probability at x is 4, and so on. And so you see that the mode occurs at n equal to 3, because the probability at x is equal to 3 is bigger than everything to the left of it and everything to the right of it. And that's answer B. Please remember, this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.